Okay, so let's talk about estimating angles. So for instance, in the last problem, we were required to know or estimate sine, cosine, and tangent of 10 degrees. And maybe we don't know exactly what 10 degrees looks like. So how would we be able to figure it out? So we have a 10-degree angle, right angle. This is the opposite side. This is the adjacent side. This is the hypotenuse here. Okay, what do these functions look like? If we were to draw sine, cosine, and tangent. Okay, let's draw an axis. Here's theta. There's sine. Let's move cosine down a little bit. Okay, so here's cosine. And tangent. Okay. Whoops. Tangent. All right. And this would be for 30 degrees, 60 degrees, 90 degrees. And what we know is that if we take an equilateral triangle, because I always forget this, equilateral triangle, that's 60 degrees, 60 degrees, 60 degrees, and this could be 2, 2, and 2. And we drop a perpendicular, and we have a 30, 60, 90 right triangle. So this is 1, 1. And we can say, great. So this one, by using Pythagorean's theorem, this perpendicular is equal to root 3. And so this 30-degree angle, sine of 30 degrees, is equal to 1/2. So if this is 1 and this is -1, sine of 30 degrees is 1/2. And we know that as it opens up, sine of 90 degrees is equal to 1. And so also we remember for very small angles, sine is a straight line. And so we get something that looks like this. Let's see if I did this right. 2, 4. Okay, I had to come down a little sooner right here. Okay, now cosine is different. It starts at 1, right? Because a very small angle, these two are the same. And it goes to 0 for very large angles because we're looking at the ratio of these two. And so for very large angles, hypotenuse gets big. And so this drops to 0 here and is at -1 for this value. Okay? And what we know is cosine of 30 degrees is equal to 0.87, very close to 1, which is the same as the sine of 60 degrees, 0.87. And we can see from this angle, that's the sine of this angle here, and that's root 3 over 2. So sine of 60 degrees is equal to root 3 over 2, which we'll find is about 0.87. Okay? And tangent is the same as sine over cosine. So for very small angles, because this is flat on top, for very small angles, such as 10 or 20 degrees, cosine is going to be about 1. And therefore, sine and tangent are the same. And so up to 30 degrees, tangent is going to look very much like sine, be a little bit bigger when you get to 30 degrees because cosine starts dropping off. And of course goes to infinity for 90 degrees and comes in from the other side and passes through 0 again with sine of 0. So it looks somewhat like that, if you remember that from trig. Okay, so how do we find out what is what is the sine of 10 degrees? Because sine of 30 is 1/2, and this is a straight line. So we could just say this is 20 degrees, that's 10 degrees. Oh, if this is a straight line, we're looking at 1/3 of the way to 30. And so rather than 1/2, sine of 10 degrees should be about 1/3 sine of 30 degrees, because it's a straight line, close to a straight line, which is about 1/6. So if you check in your calculators, you'll find that the actual value, sine of 10 degrees, is about 1/5.75. So very close to 1/6. Why is it a little bit bigger? Well, because this is a little bit curved here, right? And so it's not a perfect straight line, and so the value is going to be just a little bit bigger, but it's close. And so you can use these values, or you can use these curves in your mind to estimate the values. And again, for the test, for the homework, it's not going to be crucial that you're accurate to more than plus or minus 10-20%. I just want to see that you have some kind of idea of what the values are.